phenomena combined, you're going to get 6, 2 times 3 times 1 is 6, times x plus 3 to the 1/2 power, minus, all right, so you have 3 times 2 times 1/2, but these cancel out, so that leaves us 3, and then the 1 doesn't really add anything to this, times x plus 2 times x plus 3 to the negative 1/2 power over, now when we square this right here, this 2 squared is going to be 4, and then when you take a base with a particular exponent, and you take it to a certain power, this becomes a power of a power, which means you multiply these two together, 1/2 times 2 is 1. So that's x plus 3. Now again, this is part of the trick that we need to be careful of, because just like in the previous one, you got an x plus 3 here, you got an x plus 3 here, and you got an x plus 3 here, so that means we're going to be able to do something in relation to each of these x plus 3's that will simplify this. So what I'm going to do now, because this is actually 2 fractions, I'm going to divide, or not divide it, but reshape this into 2 fractions. So this becomes 6 times x plus 3 to the 1/2 power over 4 times x plus 3 minus, and this becomes 3 times x plus 2 times x plus 3 to the negative 1/2 power over, again, 4 times x plus 3. All right, at this point then, I am going to notice that I have 2 values that are the same base with different exponents, because we're dividing here, a fraction means dividing by. You're going to subtract the exponents, and you're going to put the answer, the positive answer, on the side where the larger exponent is right now. Well, this is 1/2, and this is 1. So we subtract 1 minus 1/2, we get 1/2, and this is going to give us 6 over 4 times x plus 3 to the 1/2 power. Minus, same thing is happening over here. We've got x plus 3 to the negative 1/2 power, and x plus 3 to the 1. So we're going to subtract exponents again. 1 minus negative 1/2 is 1/2, or 3/2. So that means that the denominator is going to become 4 times x plus 3 to the 3/2 power. And on top we have 3 times x plus 2. And I'll put the double prime x here. Okay? So at this point then, I'm going to fix this so they both have the same exponent. Okay? And so they both have 4's, but what they don't have is the same exponent here. So I can change the 1/2 to 3/2 by doing something to this fraction right here. So I'm going to make the lowest common denominator 4, and again I'm going to expand this as 1 fraction, 4 times x plus 3 to the 3/2 power. Okay? And we do the same thing we did before. So these both have 4's in the denominator, so we don't worry about that. We just look at this, x plus 3, how many times is x plus 3 to 1/2 go to x plus 3 to 3/2? We subtract these two, and you get x plus 3. The first column, which is just plain x plus 3. I'd rather not put that there, because that would be a bit confusing. So let me put where it should have 6 times x plus 3 minus And this is the same thing right here, so there's no change we have to make to this, so this is 3 times x plus 2. Now I'm going to go ahead and multiply this across. This is 4 times x plus 3 to the 3/2 power here. 6 times x is 6x. 6 times 3 is 18. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. So, when I combine like terms there, I get 3x plus 12 over 4 times x plus 3 to the 3/2 power. And again, you can leave this in that form if you want. I'm going to go ahead and factor that out. Take the 3 out, I get 3 times x plus 4 over 4 times x plus 3 to the 3/2 power. Yeah, all that work to get to that little expression. But that's how this works. I mean, the tricks of the trade in mathematics are looking for consistencies or trends of the same value showing up in different parts of these fractions, combine it into or condense it into a much smaller form. Practice, practice, practice will get you to that point. Okay? So, now, before we go any farther, now that we've got our second derivative equation here, let's go back to the original equation, and I want to point out something. This square root of x plus 3 is going to limit our interval, our overall interval. Why? Well, normally it's from negative infinity to positive infinity, unless it was trigonometric. But here, the fact that you have the square root of x plus 3, you can't have the square root of a negative number. So that means the lowest possible number you can have here is negative 3 for x. So instead of negative infinity, this is going to start at negative 3. In fact, if you do the graph for this, you will see it doesn't go, it starts at the negative 3 on the x-axis. So our interval now becomes, instead of negative pi through our negative infinity through infinity, this becomes negative 3 through positive infinity. So we got to keep that in mind. And the reason why I do that is because what we're about to do is that second derivative. Okay? So, and I'm going to re-put this right here, since our entire interval for this graph is negative 3 through positive infinity, and we're going to set this equal to 0. Okay? That means then that the value of x in the numerator then is going to be negative 4. But it can't be, because the lowest number you can have is negative 3, so that's about worthless. To get in terms of tangents, you're going to get 0 for denominator, which means that's a vertical line. If you thought of it in the first derivative, and we're kind of using that mentality in the same way for the second derivative, we're going to have an inflection point right there, but not an inflection point that's going to change positive, negative, negative, positive. It's going to change from positive to positive or negative, negative. And what I mean by that is simply our graph is going to look something like this. Well, right here, you've got inflection point, but it's going from positive to positive here. And I showed that on one graph, or it could go from negative to negative, doing the same kind of thing. So that means then that we're looking at x equals negative 3 in that respect. Okay, but the fact that it doesn't fit this right here means it's going to be it's going to be an inflection point of a curve that we are not going to be able to use as a minimum or a maximum. So, here we go. If we do this then, we're going to test from negative 3 to infinity as the only interval that we have. But I won't even bother putting a 1 down there, just an I. And this is going to be equal to, now I'm going to test 0 in here. Test 0. So I go back to my original equation, or I'm sorry, go back to my final equation for the second derivative. And so that's going to be 3 times 0 plus 4 over 4 times 0 plus 3 to the 3/2 power. So it's going to be 12 over whatever that is. When you punch that out in your calculator to figure all that out, and you're going to get an answer of 0.577. Okay? So that means it's going to look something like that. And so this point right here is going to go from positive to positive. So technically, there is no point of inflection in terms of changing directions. The point that kind of looks like an inflection point there is at a point right here where you thought it was going to start to drop, and instead it keeps going in a positive direction. So no point of inflection here. And the fact that this is positive means it's concave up. Okay? Your assignment? Page 195, 12 through 20E. When you do these problems, take your time. Double check your work, watch for little changes in negative signs and positive signs, and adding and subtracting properly, and look for the common terms that can be combined. I know when I did it a couple of times I screwed up, had to start over again, so be prepared for that. Good luck.